Okay, this is a video I hope is not too long. It's a preview to a test we will soon be having in calculus class. And here's an example problem number 1. The function g prime of x is shown on the interval, closed interval, -6 to 6, and gives g of 1. So the function g for an input of 1 has an output of 2. And this graph here we have is of the first derivative of the function g of x for g prime of x. And so the question is, the first one, on what intervals is the graph of g of x increasing? And for that, my recommendation might be to make a little number line, see what is happening, put g prime of x on top and g of x on the bottom. We really can't see clearly what g of x is doing, but we can see what g prime of x is doing. And we see a critical number here. Our critical numbers are x equals, looks like -5.5. See that? And then also at x equals -2. So -2 is our critical number. And also at x equals 3. And so g prime of x to the left of 5.5 is negative. So we have the function going down between -6 and -5.5, and the function increasing between -5.5 and -2, and between -2 and x equals 3, it's the next critical number. We also show the function increasing. And then we go to the right of 3, between 3 and 6, we have the function decreasing. So to answer this question, at what intervals is the graph of g of x increasing, we would say on -5.5, comma, -2, and you can just put and or union, -2 to 3, and for justification we'd say because g prime of x is positive. All right. Determine values of determine values of x where g of x has a relative minimum. Well, relative minimum, it's really hard to see the way this is drawn. A relative minimum would be where the function, the first derivative changes from negative to positive. And so we are, let's see, negative to positive would change right here at 5.5. So relative minimum, we would say at x equals -5.5. Why? Because g prime of x goes from, let's see, negative to positive. See, at what intervals is the graph of g of x concave up? Well, concavity is going to be determined where we have the function, the slope of g prime of x positive. And so the critical numbers here for this one will be at -4, at -2, and at 1. And so we're going to say g double prime of x, and then g of x will go down below. And to the left of -4, we have the function, we have g prime of x increasing, and the slope is going up, so we say we have concave up in this interval. Between -4 and 2, the slope is negative, so we have concave down. Between -2 and 1, we have the slope increasing, so we say concave up. And on 1 to 6, we have the slope of g prime of x is negative, so we have concave down. And so concave up would be from negative infinity, comma, -4, union, let's see, we have -2 to 1. And why? We would say because the slope, or we could say because g double prime of x is positive. Now find the equation of the normal line where x equals 1. Well, to find a normal line, we need, the equation of the normal line, we need two things. We need a point, and to get that point, we are given this point here, g of 1 equals 2. So we have 1, comma 2. And we need a slope. Well, our slope at x equals 1 is going to be right here. This is the graph of g prime of x. So slope, which is m of t, is equal to 5. Well, consequently, our normal line slope, m sub n, is going to be a negative reciprocal of 5. So the normal line slope is going to be -1/5. So our equation, I'm going to write up here above, is going to be y minus y sub 1, which is -2, equals m sub n is -1/5, and we're going to have x minus x sub 1, which is 1. So that's -1/5 with m sub n. Okay, problem 2, a piecewise function problem. And we're going to begin one of these functions. It's going to be looking something like this. G of x, let g of x equals 2x minus 3 when x is less than 2, x squared minus 5 when let's see, I got it right. Hang on a second. Got that wrong. When x is less than 2 and x squared minus 5, comma, x is greater than or equal to 2. And so you're going to be asked about finding continuity if the limit at limit as x approaches 2 of g of x. Find if that limit exists. Find what that limit is. Test for continuity. Test for differentiability. So I'm just going to have to leave you. A lot of you guys are pretty good at that. 3, we've got a problem like this. Let h of x equals 2x squared minus 3x plus 1 over x. Find h prime of 2. Well, to do that, we're going to first, if needed, make a rewrite. I'm going to say h of x equals 2x squared minus 3x plus x to the, what is 1 over x? It is x to the -1 power. Okay, next, we're going to find h prime of x, which is going to be 4x minus 3 And then for this one, we're going to have plus, and we're multiplying. So we're going to take -1 times x to the -1 minus 1, so x to the -2 power. So h prime of x is going to be 4x minus 3, and we're going to have minus, looks like 1 over x squared. And then finally, we're going to plug in 2, since we're trying to find h prime of 2. So h prime of 2 is going to be equal to 4 times 2 minus 3 minus 1 over 2 squared. So we're going to have 8 minus 3 minus 2 squared is 4 minus 1/4. So that's going to be 8 minus 3, we have 5 minus 1/4. And to put in, let's see, how many fourths do we have in 5? I think we have 20 fourths, right? 20 fourths is 5 minus 1/4. So our answer here is going to be the improper fraction, 19 fourths. Or you can put, I guess, 4.75. So that's going to be h prime of 2. There's going to be a problem like that. Okay, problem 4, limit problem. Determine limit as x approaches 3 of x squared minus 2x plus 6. We just first plug in 3, what the limit is approaching. So we're going to put 3 squared minus 2 times 3 plus 6. And all over negative 3 squared plus 3 times 3 plus 6. And simplifying, we're going to have 9 minus 6 plus 6. And we're going to have negative, in the denominator, -9 plus 9 plus 6. And so we're going to have -6 plus 6 will cancel, -9 plus 9 will cancel. So we're going to have 9 over 6, which can simplify, I believe, to 3/2. Now, in a lot of these problems, you're going to end up with 0 over 0, and you're going to have to factor and so forth. I'm not sure if on tomorrow's test what it'll be like. The thing could end up being 0. The thing could end up being just something in the numerator and 0 in the denominator, so as to be a limit undefined or no limit. So let's go on to problem 5. We're going to have a particle moving along a horizontal line, which is going to be a table where you have t and one row, and v of t are the velocity. And so at time, you're going to be given the time and the position. And so based on the numbers here in the v of t, you're going to have to determine if the particle is moving right or left. Well, the velocity, what happens when the velocity is positive? Does that mean the particle is moving to the right or to the left, or the velocity is negative? So you're going to be able to read for certain input values if this number is positive, negative, or perhaps 0. And so you have to determine when the particles are moving left and right and at rest. Of course, at rest is going to be when v of t is 0. That's going to be what? A critical number. So you might even put below this a number line, putting your critical numbers where the thing is 0, and just doing a kind of number line analysis on problem 5. Probably do that. Okay, problem 6. The table shows values for f and g, the functions f and g, and their derivatives. And so you're going to have f and g, and so you're going to say for f of 2 equals, I guess, I guess it might look, I forget exactly what it looks like, but you might have values up here. The numbers might be up here. Let's see. 2, 3, 1, and F. For F, you might say F equals 3, F prime equals, you're going to be given a whole bunch of information on this table, and you're going to be asked to evaluate what a derivative is using product rule, quotient rule, chain rule. Something could be simpler than that. So you're going to have to take these primes and F prime and F and G prime and G and use these to figure out what the derivative is. Okay, 7. This is not exactly a problem from the test, but one quite a bit like the problem of the test. Let y equals 4x times 4x minus x squared squared. Find dy dx at x equals 1. So we're going to find the derivative, and we can just go ahead. This is going to be the product of two functions. So if we call this u and v, we can call u prime is going to be just the derivative of 4x, which is 4, and v prime is going to be a derivative of this 0.4 minus x squared squared. So we multiply out front this 2, and then we multiply, let's see, we just leave 4 minus x squared inside, and we have to the first power times the derivative of the inside. Well, the derivative of the inside, 4 minus x squared, is going to be negative 2x. So our v prime is going to be negative 4x times quantity 4 minus x squared. And so y prime is going to be uv prime. Well, u is 4x, and v prime is negative 4x times quantity 4 minus x squared. And then that's uv prime plus v, and v is this guy here, 4 minus x squared squared, and that's the u prime, and u prime is 4. So just kind of combining here, we have negative 16x squared times 4 minus x squared, 24 minus x squared, plus we have 4 times 4 minus x squared squared. And we want to find dy dx at x equals 1, so I can say y prime of 1, and just plug in 1 everywhere there's x, equals negative 16 times 1 squared times 4 minus 1 squared, which is 1, plus 4 times 4 minus 1 squared, which is 1, so 4 minus 1 squared. So we have negative 16 times 3, 4 minus 1 is 3, plus 4 times 4 minus 1 is 3 times 3 squared is 9. So we're going to have negative 48 plus 4 times 9 is 36. So our answer is going to be negative 12. So you can have a problem similar to this one. Okay. Next, 8. Interpret graph of twice differentiable function And the answers are multiple choice options requiring understanding of the relationship between f, f prime, and f double prime. It might help you to remember back the day before Halloween, I think it was. Was that when it was? No, it wasn't the day before. It was the day before homecoming. That's what it was. When we went over to Langdon Road and did our little experiment with concavity and so forth. 9. Particle moving along the y-axis problem given a position equation. And you're going to find velocity at a particular time when particles at rest. So you might have a function like, I don't know, x of t equals 2t cubed minus t squared plus 6 or something like that. We find the first derivative of this position function to find velocity, to find when the particle is at rest. We set the first derivative of this thing equal to 0, and then finally, if the speed of the particle is increasing or decreasing at a particular time, well, what we need to do to find speed increasing or decreasing is go on to find the second derivative, which is acceleration, check for concavity. All right, if the function is, if velocity, where velocity and acceleration have the same signs, either both positive or both negative, the speed of the particle is increasing. 10, definite integral problem. Well, it's going to be one of these we've had since day one, where we have, say, a function from, let's take one, we'll go from -2 to 2 of x dx, right? And what we need to do is simply draw a graph of what this looks like, and we have, boy, I'm not getting these nearly vertical. Okay, that's a little better. Okay. Well, we have, that's our coordinate graph. We have the equation y equals x. So we're talking about this diagonal line here. And we're going between -2 and +2. And what we're doing is we're looking at the difference from the x-axis here. So we simply draw these little vertical line segments. And between -2 and 0, we're shading this area, okay, between the function and the x-axis. And to the right of 0, we have this thing shaded in. Well, these areas, even though it doesn't look like it, are going to be, what do you call these things? Let's see. Equivalent, I forget the word, identical. So these things are identical, and so you're going to have a negative here and a plus area. I guess this would be probably a 2 by 2 divided by 2, so this would be -2 plus 2, and so our net area between these two is going to be 0. So I'll just draw a little graph, see what the area is on that. 11. Now find the intersection of two functions problem. We have y, and it's going to be two functions in quadrant 1. And here we have a sample problem. I have different equations, but we have y equals 2x and y equals x cubed. So here's the function, this kind of slope of 2. This is going to be y equals 2x. And we have y equals x cubed. Y equals x cubed is going to look something like this. It'll come up like this. And it's going to go, and there's going to be some intersection point someplace here. And to find what that is, now there's going to be an intersection at 0, but we're looking for this intersection up here. We're going to set 2x equal to x cubed. And to do this, we can solve by factoring. And for that, we'd have to subtract 2x from both sides of the equation. So we have 0 equals x cubed minus 2x. Factor out an x, so we have x times x squared minus 2. And so we'll have an intersection where x equals 0, but that's not what we're really looking for. But then we're going to have x squared minus 2 is equal to 0. So we add 2, we're going to have x squared equals 2. And so we're going to have x equals plus or minus square root of 2. And so what we need to do is the intersection is going to be found at an x value of square root of 2, and then we can use either function since the functions intersect. Our y value is going to be 2 times x, which is 2 square root of 2. So this is going to be our intersection in the first quadrant of these two functions. Okay, problem 12. Find the limit as h approaches 0 of 2 times quantity x plus h cubed minus square root of quantity x plus h plus 2 minus 2x cubed plus square root of x minus 2. Well, this function is in the form of definition of derivative. So the function, if we're going to call this function f of x, is equal to 2x cubed. And to verify, we have a minus f of x here, so that's right. And we're going to have minus square root of x. And the minus of that is over here, so that would be plus, and plus 2. And so the limit as h approaches 0 is going to be the first derivative of this guy here. So we're going to rewrite this function as f of x equals 2x cubed minus x to the 1/2 power plus 2. And f prime of x is going to be 6x squared minus, we're going to have 1/2 x to the 1/2 minus 1, x to the negative 1/2, and the derivative of 2 is 0. So just rewriting in the radical form, we're going to have 6x squared, and we're going to have minus 1 over x to the negative 1/2 power. We have 1/2, so we're going to have 2 square root of x, and that is 0. So this will be our answer, except we're not going to write it that way. We're going to say, let's say, we can write on the right side, equals limit as h approaches 0 of so you have an equal sign here, and you could put that up there and get, I guess you can actually box this in as your correct answer. Anyway, that's a summary of the test. Not exactly what's going to be on the test, but the types of problems. And I'm going to post this shortly, and I certainly hope this is helpful to you. Thanks for viewing.